Awesome. Okay, welcome everybody. Welcome people online if there's anybody watching right now or who's watching the recording. So it's really great to be here, and I'm going to speak about implementing GitOps best practices with Crossplane and ArgoCD. By now you had time to read the title probably several times. So I'm going to talk about deployment methodology, which is called GitOps, that I got a chance to work with a few years when I got started a year ago when I got started in the DevOps space. And then I'm going to talk about two cloud-native projects, namely Crossplane and ArgoCD. Now, you see in the corner here a company called Upbound, and it's there because our integration at Sivo with Crossplane broke down due to some updates, and I'm off on vacation this week, so I didn't bother to fix it. So you're going to use Google Cloud, and Upbound is the company behind Crossplane, mainly behind Crossplane. So that's why the logo is there. So don't yeah, that's just to mention it. You can find me on Twitter if you have any questions after the talk, or if you just want to say hi, or if you take some pictures, you can tag me on Twitter. I'm very active on Twitter. Now, a bit more about myself. I don't know who, I spoke to some people earlier. I was working for several years in the blockchain space, and then a year ago, got approached by a company called CodeFresh, which do CI/CD platforms, and that was my starting point in the DevOps space. So fast forward, I'm since about half a year a site reliability engineer at Sivo. Sivo is a cloud computing company that's based on Kubernetes, so our main offering are Kubernetes clusters, and our goal is basically to make Kubernetes as easy and straightforward as possible. And I'm also studying for my computer science degree right now, which is kind of like both. So I just want to make clear I'm doing this since like a year. I'm going to try to answer questions to the best of my ability, but bear all of that in mind. Yeah. So I'm also, like mentioned, a cloud native CNCF ambassador. And the CNCF, for those who, I don't know, who knows the CNCF? Hands up. Okay, you all know. Oh, mostly. Okay, just recap. The CNCF is basically a baby within the Linux Foundation, and that's how I put it. So they're part of the, within the Linux Foundation, and they're responsible for hosting or providing a neutral ground for cloud-native projects. So open source projects that are based on Kubernetes and or to enhance the Kubernetes stack, let's say. And basically lots of projects, they are donated towards the CNCF, and then they go through a process from first being a sandbox project to incubation when they get more resources by the CNCF, and then to graduation. So this is the CNCF landscape. There are some of the projects that they host, mainly the big ones. Oh, you can't see it. Can you see my mouse? Mainly like, for example, Helm is within the CNCF. Here's Crossplane that we're going to talk about tonight. Then there's Kubernetes, which is a graduated project from the CNCF. And more projects are members. So a lot of these projects are members. You can also see Sivo here somewhere. Over here, Sivo, which is a member, or like a distribution in that case. But there are lots of member projects. So it's not just that all these projects are actually hosted within the CNCF. Yeah, and I also do YouTube. That's kind of how I got started in this space. I was thrown into a job where I've never heard about Docker or Kubernetes or anything related a year ago, and I was like, well, I should probably learn this now, given that I'm paid to know it. And that's when I started. That's when I started my YouTube channel. So now I have like over 60 videos of me mostly just sitting in front of my computer and trying to learn something and trying to figure out the documentation of various projects and trying to understand what they mean by what they write. So that's always fun. And I just film myself doing that. But let's move on to the content that I want to talk about tonight. Or before we do that, I like to kind of give an outline of the goals that I have in mind when I talk about these projects, or like some of the aspects that like when I talk about all these cool cloud-native projects, they're obviously, you want to do it with you want to implement those tools with a purpose, right? You don't just want to go ahead and be like, oh, which project do I select today in the cloud-native landscape and implement on my stack? Because that would be quite counterintuitive to use that approach. So what are the goals when we talk about these cloud-native projects? What do we actually want to achieve? Well, first of all, we want to get really excited, or I want to get people really excited about using Kubernetes, about using cloud-native projects, and yeah, getting started with the cloud-native ecosystem. So my main goal is just to show people, like, if I can use these projects, so can probably you. So, and it's really easy and straightforward if you look at them and just with the resources available online, and yeah, just get people excited of what they can do with those projects and those new deployment methodologies that GitOps and so on enables you to do. And then the second thing is that we want to prevent being in this position of well, us having infrastructure that's very difficult to manage, and us kind of being this middleman of just having to keep doing things that we don't really want to do just to make things work. That's really what we don't want to end up doing, right? And similarly, when we implement new projects into our stack, right? Like a lot of times, those new projects, they're really exciting, and we want to implement them into our existing tech stack. But ultimately, if they don't work well with our existing, maybe even with our culture within our team, or other processes and other tools that we have within our team, then they might also be counterintuitive to implement, and we would have to maintain them manually, maybe even long term, which we don't want to do that. So we don't want to end up there. And then some other factors that I like to keep in mind when I'm talking about these cloud-native projects, that throughout our entire deployment lifecycle, however that may look like for your personal projects or for your team projects or company projects or whatever, there are obviously different communication patterns that are already in place, different expectations between team members, between different teams. So implementing a completely new deployment methodology or way to manage your infrastructure will have an effect of these different aspects, like on your communication style, maybe on the different dependencies between different teams. I talked to people where they had in one team everything cloud native, Kubernetes based, and in other teams they didn't have that, right? So obviously there are different dependencies that you have to manage and that you have to deal with. And then also another big factor is that with these cloud-native projects, you have to spend some time learning about them, right? And sometimes it takes a long time to implement them properly and to configure them and everything. And something that happens a lot is that you have, like in the end, one team member who knows how to configure a tool, for example, for your monitoring stack, and the other team members just don't know how they would go about using it. So a big factor is also then implementing knowledge transfer. So there are lots of these invisible aspects that I think the cloud-native space and ecosystem just kind of has an effect on. Yeah, and then just some of the other things that we want to keep in mind is, or like with those projects, my goal is that, or like if I'm implementing a new project at Civo into our existing tech stack, I want to keep in mind that we have high portability, so we can easily, like if I'm implementing a new tool, I want to ensure that we can still switch to other tools in case we realize this tool that we currently have in place is now good for us. For example, we used for a long time one storage provider for our storage nodes, and now we are going to switch to another one. And so high portability is really important to be able to keep, for example, our offering cost effective. Then another aspect is high agility. So we want to be able to respond to customer and internal requests as fast as possible. However, these two things are only possible if we have high observability into our deployments. At Civo, and I'm going to show you that in the next slide, what we do basically, this is from a talk that I did at KubeCon this year with my manager, and what we have at Civo is we have several different regions, and within those regions we run Kubernetes clusters. Those are our super clusters. So this is basically one of the super clusters, and we have compute nodes in that region, like on that stack. Those are the compute nodes. And on those compute nodes, we schedule the tenant workloads. So if you spin up a Kubernetes cluster on Civo, it's scheduled on any of those workloads, of those compute nodes on that supercluster. So obviously there are lots of different moving parts of managing Kubernetes inside of Kubernetes. You basically have Kubernetes inception, and you have to figure out what is going on where, right? Oh, by the way, if you have any questions, feel free to interrupt me. Like if there's anything where you have common thoughts or questions, interrupt me, please. Or can we do that, or can we not do that with the microphone? I prefer that instead of me going on of something and you're like, what? That would not be too good. So I prefer being interrupted, just FYI. So obviously, when we implement new observability tools into our existing tech stack at Sivo, to reach high observability into the workloads, what's going on where, how can we debug it better, it can come at high operational management. So if we implement new tools, somebody has to manage it. Somebody has to take care that it's still working in the long term, right? And that's also like then related to knowledge transfer of those tools. If somebody is implementing it, how do you make sure that the other team members who didn't have a chance yet to implement those tools actually know how to do it or how to manage it long term? And then ultimately, Kubernetes is complex. It's difficult to configure. And if you don't configure it properly, you might end up with unnecessary security risks that you implement into your workloads and into your environments. Yeah, so I used this slide for quite various talks, so I'm not going to go further detail on that. But yeah, ultimately, we want to prevent the following: over-engineering of our application. So I completely acknowledge that any of those tools that I'm going to talk about tonight might not be necessary for your team or might just not work for your team. Like, we don't use ArgoCD and Crossplane at Sivo because it's just not, it's not a necessity. We just don't do it, right? But I love to show them in demos because they kind of show this is what you can do within the cloud-native ecosystem, which I really enjoy. And then we want to solve actual business problems. Like, we can implement those amazing tools that look fancy, and it's like everybody's talking about Kubernetes, let's implement those tools, right? But if it's not actually helping us, or if there are cultural issues within the business that kind of make it a problem or so on, then it might not be the best way forward. And then we want to ensure that we build reliable services, and that's also related to the security part. Now, how do we get to all those goals that I just outlined, and how do we get there with Crossplane and ArgoCD? I usually have like some slides on like overview of Kubernetes, but hands up, who knows, who is using Kubernetes on a regular basis? If I can just see that. Okay, many people here are, so I'm going to keep this quick, because usually I talk to people who have never used Kubernetes in their life, and then they obviously have to elaborate a bit more, and this is actually the first time that I'm speaking in front of people who remain like you know about Kubernetes or using it before. It's cool. Awesome. So basically, when the idea is that we break up our monolithic or large-scale applications into separate services that can operate independently. So let's assume that service 1, service 2, and so on, they all are divided, or they run on several containers. And those containers are decoupled from each other, meaning you should be able, like, even if service 2 is dependent on service 3 in some way, you should be able to make updates to those different components independently. And if you have the application and the workloads decoupled from your infrastructure, your environment, then you can basically set up your infrastructure, your environment, and keep that all in place while you do updates to your deployments in its simplest form. Well, that's like how I explain the slide usually to get the message across. But the thing is that there are lots of companies that, or like you easily end up in a situation where you have lots and lots of containers and workloads that you have to manage, and then you need additional observability and you need additional processes to actually manage those containers, those workloads, those microservices that you want to deploy on a regular basis between teams that don't know even about their existence. And that's where Kubernetes helps us. Now, I usually just show this as a simplified, very simplified version of Kubernetes, of what's going on in there. And the main goal here is basically that when you spin up a Kubernetes cluster, it consists of several nodes. And those nodes then run your workloads. Now, usually you don't really care which nodes those are. Like, if you are in more complex environments, you might have storage nodes, you might have nodes for particular tasks. But usually, if you just get started with Kubernetes, you don't really interact with the nodes directly much. It's just basically you tell Kubernetes through the Kubernetes API and kubectl, the command line, just, hey, here, go ahead, please deploy this workload for me that's defined in YAML manifests. And then you tell it how many replicas to deploy, and those are then scheduled within pods usually, which is like one of the smallest units of workloads within your Kubernetes cluster. And they are dependent on other Kubernetes resources. But the real power of Kubernetes lies in the Kubernetes API, and companies and projects being able to expand upon the Kubernetes API. And it just then becomes like this platform where you can run any tool that's defined within the Kubernetes specs on top of your Kubernetes cluster. And we're going to see that as well with ArgoCD and Crossplane. So the main problem, however, is that it can easily get very, very complex. Our main goal is when we move towards a cloud-native ecosystem and managing our workloads in a microservice fashion, that we basically end up having to manage our infrastructure less and less. But ultimately, with Kubernetes, it can easily end up being the scenario that you have to do a lot more. And that's kind of counterintuitive. Now, there are projects such as Knative, which is also part of the CNCF, that allow you to run serverless workloads on top of Kubernetes, which is actually pretty cool. But it's also only serving limited use cases, I would say, or at least the way I used it. So it's not like universal solution for everything for you to write less YAML files. And then obviously with the cloud-native landscape, it can easily happen that you either go completely over the top and you just go ahead and want to deploy everything, or you end up in a scenario where you're like, oh, this is maybe not too much, or you end up easily in the situation where you deploy a lot of things and then you don't know how to go about managing those. And ultimately, I'd just like to show this for fun, is that we don't want to go ahead and just come up with techie things that we deploy and then have to manage and use. You can read that later, or pause the video later or something. So let me tell you about GitOps and ArgoCD and why I really like those ArgoCD and Crossplane as tools within the cloud-native ecosystem. If I speak too fast, you can tell me as well. Like, please stop me. So ArgoCD, part of the CNCF, part of the cloud-native ecosystem. Argo is basically the umbrella project of 4 projects, which is Argo Workflows, which is more or less like, basically having workflows similar to CI/CD pipelines, but a bit different. And then Argo Rollouts is, you use it for canary deployments and more advanced deployments, which is pretty cool actually to use. So you can like have automatic rollbacks of failed deployments and so on. And then Argo Events is to trigger the other components, or like trigger other things, basically, to happen. And then ArgoCD, which we're going to focus on, is a declarative GitOps delivery tool for Kubernetes. So what does that mean, declarative? So basically, imagine it to be like this. When you manage something declaratively, you already know the end state. You already know where do you want to go in the end. So you don't just, for example, it's similar to cooking. when you cook, like, let's say you want to cook the amazing lasagna that you had the other night at the Italian restaurant. And with the declarative approach, you already know what has to go into the lasagna to make it perfect. You already know each of the steps, and you just have to basically give it to somebody and it's done, right? With the imperative approach, what you do instead is you just keep mixing things together and hope that at the end you will have this amazing lasagna, which will likely not happen. And that's kind of compared to when you click buttons in a UI, that's the imperative approach. So if you configure your infrastructure through a UI, you just click things, and then maybe the UI changes and somebody else has to the next time click other things, and you don't really know how to replicate the workflow. That's the imperative approach. So the declarative approach is basically you already know what has to be defined in the end. What is your infrastructure supposed to look like in the end? ArgoCD also has a really comprehensive UI and CI, so we're going to use both tonight, I think, if I get it to work. And then you can deploy YAML manifests for customize, Helm, plain YAML files, whatever you prefer using. At Sivo, for instance, we use Helm heavily for our infrastructure deployment. Now, ArgoCD is so powerful because it allows us to get into new deployment models and shift our infrastructure left. Our engineers can actually make changes in a secure fashion. So imagine that basically, or like the main premise of GitOps is that Git is your single point of truth. And I know that you had like before a talk on ArgoCD from one of the maintainers. So has anybody been to that talk before that was here from the same meetup? Somebody mentioned, no? No, one person. Okay, one person. Okay, you tell me. Okay, cool. Okay, so I'm going to repeat this. Has anybody here used ArgoCD before? Oh, cool, so many people. Wow, okay, so you know how it works. So this is mainly like for people online, I guess, and half of the people here didn't use ArgoCD yet, so or heard about GitOps. Yeah, so the main thing is that everything from your infrastructure to your workloads to your application, everything that it can be dependent on, everything should be defined in Git. Like all your secrets, everything should be in Git. And that allows you to track the changes over time of your deployments in Git. And similarly, if everything is in Git, you can then deploy agent, which in our case is ArgoCD, on top of your Kubernetes cluster. Now, why do you want to have an agent running within your Kubernetes cluster instead of pushing changes from Git or from your local environment to the Kubernetes cluster? Because you will need access to do that. Like if you don't have something running inside the Kubernetes cluster that pulls the changes in from Git, you will need to have somebody else, to give somebody else outside with an application, a platform or something, access to the cluster to make changes. And that's less secure. So you want to have an agent running within your Kubernetes cluster that just sees when there are any changes within Git and just pulls them in. And so the main thing here is the access control, or the part that I really like, is that you have, instead of an external application being able to access your Kubernetes cluster and pull information out, you push information out from the Kubernetes cluster, and that makes it overall more secure. And you can allow people to make changes to the Git repositories and have the specific checks in place before changes are pushed to the main branch, versus having to allow people to manually do updates to your Kubernetes cluster, because then you don't know what kind of kubectl commands that people actually use, right? You don't know how to replicate that in many cases. So that's that. And we want to go GitOps all the way, and that's what we're going to do with Crossplane. We want to use GitOps not only for our workloads, for our deployments, but also for our entire infrastructure. Who has used Crossplane before? Hands up. 1, 2. 2 people. Oh, yes. OK, I like that. Awesome. OK, so Crossplane is basically similar to ArgoCD. If you've used ArgoCD before, what you do with Crossplane is similar. You have a Helm chart usually. And I can show you that in a second when I go to the demo. And you deploy that Helm chart that has all the YAML files that Crossplane is dependent on. You deploy it on top of your Kubernetes cluster. So it's basically similar to how you install ArgoCD, right? You would install just Crossplane, right? And their YAML manifests. So the installation process is pretty much the same thing. And then with Crossplane, you have providers. And we're going to look at that in a second as well in my demo. And those providers, they're Azure providers, they're AWS providers, they're Google Cloud providers, they're all kinds of different providers for any form of infrastructure that you could possibly spin up and manage. There's also a Civo provider that sadly failed me tonight. So that's why I'm going to use the Google Cloud provider tonight. Yeah, so with Crossplane, you can basically, what you do, you tell it which provider to use. And let's go to the next step. That's what you do. OK, let me walk you through this. This looks complex at the beginning, but it's actually not that complex, I promise. I try. So first, you go ahead and you install the Crossplane custom resource definitions, the Crossplane custom resources. That's what you do first. And they are running within any Kubernetes cluster. That doesn't matter where. It doesn't have to be on the same cloud platform that you're using. Like if you use AWS, it doesn't have to be on an AWS cluster. So you have any cluster. It could be a kind, microK8s, or any other cluster that you install Crossplane on. Now, once you have that, you need a provider. You need to basically tell Crossplane how to access the API of one of those external platforms. So you install the provider. And that's usually just like one command. You give it to the Kubernetes cluster, and it's just going to install everything that the provider needs to operate, to run. But at that point, the provider out of the box doesn't have access to your account. So for example, if you use AWS, the provider doesn't have automatic access to that account that you want to use, right? For instance, to my Civo account, right? I need an access key to give that to a platform or somebody to actually allow them to access and interact with my Civo account. So what I do next is I create a Kubernetes secret, and I give that secret to the provider. And that's like the first step. And at that point, the initial Kubernetes cluster knows how to access the external platform and interact with my account, and with the right access rights, it can then create resources on that account. Now, how does it create resources? So as a last step, I would go ahead and I would give, in this case, that Kubernetes cluster, the original Kubernetes cluster, a YAML manifest that defines how my cluster has to look like. So it defines basically how many instances I want to run. It defines how large the instances should be. It defines the region that it should run. Everything that my cluster is dependent on will be defined in that YAML manifest that I then give to that original Kubernetes cluster. Now, once it's deployed on a Kubernetes cluster, Crossplane will see it and be like, oh, this is something that I'm responsible now for managing. It's part of the Crossplane API on top of Kubernetes. And it's then going to go ahead and it's going to communicate through the provider with the external platform, in this case Civo, and tell the Civo API, please spin up this resource, exactly how I define it. Now at this point, the resource, the Kubernetes cluster that I'm spinning up is managed by Crossplane. So I can't just go ahead and go to the platform and just delete the resource. If I delete anything that's managed by Crossplane, Crossplane is then responsible through its basically, it has like a loop where it's continuously watching your resources, continuously asking Civo like, hey, is the resource still there? Is it still there, right? And it's basically requesting the information. And if it's not there anymore, the platform will flag it to Crossplane. Or like Crossplane will see that and will just spin up the resource again. So anything that you manage through Crossplane has to be managed through Crossplane. Now, why is this so amazing? Because you can basically, the idea behind Crossplane is that you can set this all up, right? And this is kind of the next step. So bear with me here, okay? So you set up Crossplane, like I just mentioned. Then you can set up ArgoCD, for instance. And then you can connect it to a Git repository as like a next step. So you set up those two tools, then you connect them to a Git repository, and you can allow developers, engineers, anybody to deploy the resources that they want to spin up, to deploy to that Git repository. And that makes it possible for people to spin up resources without actually having to interact with the actual Kubernetes cluster. So, for instance, in very large organizations, you have to request new infrastructure, new resources, whether that's for testing purposes or other purposes. You have to like request them, and then it's a process to create them. And with these tools, you can basically allow people to create their own resources and to be more productive. That's the idea. And also to manage the access rights and the security in place. Because if you manage access rights within Kubernetes, it can easily get very complex. And this kind of allows you to manage the access right to the Git repository and then just connect the Git repository, like the Kubernetes admin would then connect it to ArgoCD. And ArgoCD will then basically, once you deploy something on your Git repository, it will pull that resource out and it will go ahead and deploy it to that Kubernetes cluster where it's running on. And then once it's deployed on a Kubernetes cluster where Crossplane is running on, we see we have basically the previous, jumped ahead, the previous process where then Crossplane goes ahead and can communicate through the other platform's API and create the resources, whatever you want to spin up, whether those are databases or clusters or any other form of infrastructure. Crossplane can then communicate with all other, with those other platforms and spin up the resources for you. That's the idea. Any questions so far? Or comments on this? Anything? No? Nothing? Wow, you're shy. Okay. Okay. Usually I get lots of questions of yeah.
I have one comment.
Mm-hmm.
So basically, ArgoCD together with Crossplane, this is like a giant operator with plugins to different cloud platforms.
Yeah.
So if I declare I want to have a high availability group in North Virginia and AWS, I just declare YAML. The operator sees this for me, takes my keys, my AWS keys, and talks to the API, and then I get the stream.
Yes.
Could I just repeat for the screen?
So, so basically what you do is, if you want to have in any, in a specific region, like a high availability cluster, resource, whatever, you just give that to your initial, in that case, you want to make sure that the cluster that you run Crossplane on and ArgoCD on, it has to be available as well, right? It has to, because ultimately what you don't want to happen is that goes down and then some modification happens to the resource that you actually want to use and that you're dependent on, right? So you kind of create, but it's like an additional layer of security. So you have, abstraction of you have your resources managed through Crossplane in an external cluster it's external to the resources that you create, right? It doesn't have to be on the same platform. It can be on another platform. You can manage, for example, AWS resources from Azure. That could work. Like that, you can do that with Crossplane or similar plug and play. And that also allows you to be less dependent on specific cloud platforms, on specific providers. That's kind of the idea behind it, that you can easily switch between them. And that's also what Upbound is ultimately working on, to use Crossplane for that, to allow people to have like this single point where they have multiple infrastructure from across different resources and platforms. Yeah, so you basically have this original cluster, and again, it can be any cluster. It doesn't matter what cluster it is. Now at Civo, we run K3s clusters, so it could be that. It could be a normal K8s cluster. It could be on your local machine. It could be anywhere. But if you want to have it really like, it's crucial for your deployment, you would want to have it somewhere where you can also be dependent on a cluster. It's a bit of a lot of the comments around Crossplane is a chicken and an egg problem. You need to have an original Kubernetes cluster to spin up all your other workloads. That's ultimately it. How much time do we have right now? Like, what time is it? I can see it. Okay, that's good. Awesome. Okay, so we have over here, I prepared some stuff. I have here my original test cluster. I hope this is still connected and everything. I hope you can see that. Let me just make this bigger. So this is my original cluster, and I'm connected to this original cluster over here. And is this big enough? It's big enough, right? So I have here my nodes running, and then I have, it will hopefully connect. Come on. Okay, so my nodes. And then I have already set something up because I gave a similar demo, a bit different, a while ago, and I realized that I was setting up everything from scratch, and it took some time. So I have set up ArgoCD, and I have set up Crossplane. Crossplane, it's pretty straightforward. You literally just go to the installation, and then you have here the self-hosted option, and you go ahead and you deploy the Helm chart. That's ultimately what it is, right? It's the Helm chart that runs Crossplane. So you can get all the resources within Crossplane, and that's ultimately what I do, right? I just go through the documentation, and as you can see here, this is everything that's running on Crossplane right now. Now, this is specific to GCP here in this case. When you use Civo, you have a few less resources running inside of Crossplane. It's a bit less. So what you do next is Crossplane provides you with like the pathway, let's say, to connect, to set up the connection to GCP. So I could have this cluster over here. I could have had that in any other account. But ultimately, I'm connecting to it, and then I'm setting up, through these commands, I'm setting up the connection to my, can you see this? To access the platform. A little bit. Is this bigger? Better? A little bit? I'm going to show some other stuff. Okay, that should be good, right? Okay, so you just basically set up the resources that are needed to connect to the specific provider, to the specific platform. Again, with Civo, it's a lot simplified. So I was like, I realized it wasn't working yesterday, so I was trying to figure out how to use GCP again. So this is ultimately, it's pretty straightforward on how you then connect to it. Now, based on this, you create, based on this here, those information, you create a credentials file. And based on that credentials file, you then create a secret. And that secret is living within your original Kubernetes cluster. And it's referenced within your provider config. So the provider config just basically references the secret and tells Crossplane how to connect to my GCP account. That's all it does. Is that right? Cool. So once we have this, I basically gave this already to my cluster. I can probably, I can show you that it's right there. It's living within my cluster. So if I look for provider, it should show up. Maybe it's not showing up. Providers or something else, some other resource. Okay, maybe I shouldn't have shown that. So I already gave this actually to my Kubernetes cluster, so it should know about the provider. It's probably named differently. My provider config, if I look for my provider config, it should have that within my Kubernetes cluster. And then what I want to do now is that I want to tell I want to tell that cluster to create a new cluster, to create this cluster over here. And as you can see, this is the Crossplane specific API. So I'm using that. And I'm creating a new resource, a cluster resource. And it's basically just referencing the provider. And what you basically do with Crossplane is this already here, what you see here, this resource, this YAML resource, already creating the cluster. What you can do with Crossplane as well is if you want to limit people and what they can create and what type of resources they can create, you can have a other resource that you deploy before, that you deploy on your cluster before, that basically says you can only create, for example, small to medium-sized clusters. So you can limit people in what resource they can actually deploy on top of Crossplane in the end. And that's all referenced within their documentation. It gets a bit more complex, but ultimately, what I'm doing here is just I'm creating a cluster and a node pool. Again, for Civo, it's just like one little file where you specify everything. Here you need 2 resources, and then it's creating the cluster, supposedly. So I could go ahead now and just deploy that through kubectl directly to my cluster, but I want to use ArgoCD that's also running within our cluster. So we have ArgoCD running over here within the cluster. So if you look at the namespace, and now I want to log into ArgoCD, login, port forward, kubectl, port forward, and ArgoCD. And now from my other terminal, I can log in. So I can show to you, for those who don't know it yet. So I'm logged in now, and I want to connect it to this Git repository that I set up before. So somewhere over here, I have a Git repository between the other repositories that I want to show you. And right now, this Git repository is completely empty, right? And I want to basically tell people that this is the Git repository where you ultimately give your infrastructure files to, and then ArgoCD will deploy it. So we now put that over here, these resources, we put it into the Git repository over here. So we add a new file. Oh, add file. Happens when you're nervous. Add file, create new file, and then we just create a cluster YAML. And I'm going to post that here. And that's all I'm doing. I'm just giving it exactly the same resource. And now I still have to tell ArgoCD about this. So this would be done by the cluster admin, that they tell ArgoCD which GitHub repository there is that they should connect to. So it's basically ArgoCD app create, I think. Okay. So I'm going to create this application on ArgoCD called well, in this case, cluster, and I'm giving it the Git repository with my Crossplane resource. So I'm specifying that, then the path of where the YAML manifest that ArgoCD should deploy on top of the cluster, and then the destination Kubernetes cluster, which is the one I'm currently connected to, and just going to use the default namespace. And now ArgoCD should go ahead and create that resource. And at the beginning, it's not synced. So you basically, ArgoCD, what it does, for those who don't know, it has like points where it auto-syncs, so it can auto-sync with your Git repository, but it can also, you can also manually sync it to make the process faster. So ArgoCD app sync. And now it's going to go ahead, and it's hopefully going to sync it. And once it's synced, we can go ahead and open open the UI, and then we can also see it within the UI. And here's our application, and we can go ahead, and we can also see what's being created, and it doesn't know about the resource. So usually you would have here, if you give it like an application, right, you would have, and this is the first time actually seeing it in the UI. So it's interesting that it doesn't show up in the UI, since it's a specific resource, like it's specific to Crossplane, right? Like, so ArgoCD probably just doesn't know that this exists, right? Because it's crossplane specific. Yeah, there's a question.
There was just network resources selected, or when you go
Do I have
to
to?
the upper right, there, and then
What do you do?
The left.
This one?
Yeah.
Oh, here we go. Oh, awesome. Cool. Here we go. So, yeah, we have everything here. Thank you. I learned something new. So awesome. Okay, and now we can go ahead and we can go back to our Kubernetes clusters, and it should have created a Kubernetes cluster now. That's the idea.
And beside that, there is within Argo Lab some extension part where you could extend your Argo UI.
There is?
Yeah.
I should spend more time on this.
Organization.
Okay, so there is a part within ArgoCD. It's getting more and more complex, so you can so you can extend it to know about more resources. Where, over here? No. Oh, this is the first time I'm looking at.
The Argo Labs GitHub organization.
To the, how do you go there? Here?
It's a separate deployment you have to add, similar to.
Oh, it's like I extend the ArgoCD resources to know about more stuff.
Yeah.
Okay, awesome.
Within the UI by that.
Oh, that's cool. I didn't know that. Awesome. Okay, so you have that over here, right? And then you have here, what I want to show is you have now the cluster that's just spinning up, right? It takes a bit of time. And now you all have to go like, woo, right? It's there. Please, like, woo, yay! Awesome! And then you can basically, usually what happens, and I haven't tried it with GCP yet, but what happens is you have in your original cluster, you will have a secret. And that secret reference the kube config on how you can connect to that new resource. Now the thing is, what I found interesting here, because whenever I give this demo on Zivo usually, when I go ahead and I delete the cluster, Crossplane is responsible through its reconciliation loop to just recreate the cluster, right? So I wouldn't be able to delete it. Now what happened here is that I can't even delete it. So I can't delete this cluster through the UI. I can only delete it, in this case, through ArgoCD by just deleting the resource. So I can delete the original cluster, but in this case, I'm not able to delete that cluster. If I would delete the original cluster, I would probably be able to delete this cluster as well. But that's basically the magic behind it. And so why I have all these different Git repositories up here? Well, first of all, here's the provider. So when you look for different providers, I would always go to the Crossplane GitHub repository because it's the most it's more comprehensive than the documentation. And you have all those different providers here. You also have a separate repository, which is Crossplane contributor repository. And there you have more providers that you can connect to. And then this is something else. And then this person over here has also their developer advocate at Crossplane, Victor Fasik, and he has a bunch of different tutorials on how to get started with Crossplane. So if you're curious, I suggest you to check that out, like his repositories and his demos. And he also has a YouTube channel, so check that out if you're curious on using Crossplane. But yeah, there are lots of different examples on his, and that's also how I got it working. So kudos to that. Yeah, and that's basically what I wanted to show. So are there any questions at this point? There's one.
Okay, so my question is your, can I have the mic?
Yeah, sure.
Okay, sorry.
Use it.
Okay, so my question is, how does Crossplane compare to the cluster API? Is it like building upon it, or is it like alternative to it?
It's building upon it. So it's basically like, it's similar to an operator. Like that you, well, but based on Kubernetes. So you basically, everything you deploy from Crossplane are just Kubernetes resources. So you have the operator code in containers running, and then you deploy those. Or it's basically, well, no, the provider itself is also an OCI image that you deploy to the cluster. So basically, if you go to the provider, you just give it, let's say the Azure provider, you just give it the image to Kubernetes. Where is it? Not here. Okay, it had the GCP one had the image referenced. It's interesting then, yeah? Okay, wait, 1 second. I want to show you. So here's the command somewhere, or not. On their documentation, that's where I got it from. So here, basically here, that's what you deploy. That's the provider that you give it. You just give it the the image to the resources, and then it's going to spin it up. Does that answer your question?
Yes, but I was like wondering if it's like if it's reusing the same code of the cluster control. So there's like a command line tool to do what you just showed us, just like to do directly to deploy different clusters on different cloud providers. It's called cluster.ctl, and it's probably using a lot of code from it, but I don't know.
So when we developed the Sivo provider, it was literally like similar to developing an operator, and then based on that, they created the image. That was kind of the process. Yeah.
Okay, thank you. Some other question from the audience?
Somebody else? Maybe there are questions also online.
Yeah.
Are there any? Did people watch?
Yeah.
There.
I'm just curious, you mentioned you don't use ArgoCD and so on at Sivo. So what do you use for deployment?
There's a really good talk that we did on the Sivo YouTube channel, which was basically a live meetup that you can also rewatch if you're curious. Basically what we use is we use Terraform and Terragrant to manage our deployment. So we basically have Excalibur. I can show you, like, let me look that up, this tool. So this is like a drawing tool where I also drew this. How do I go to the left? Okay, so what we do is basically we have Terraform, and then we have Terragrant. And what we have is we have here our different Helm charts within Terraform. So we have our different Helm charts, and they are like all there. Sometimes some of them are customized, some of them are just from GitHub out of the box. And then we have here in this might look horrible. Can you see that? It basically it's better explained in meetup. We have in Terragrant, we have for each of our regions, we have the specific values that are deployed in each region. And then basically Terragrant is responsible for plugging the values into the Helm charts. Like for example, if like we can't have for our London region the same values as for our Frankfurt region. So we have Terragrant that basically gives the values to the Terraform deployments. And then Terraform is gonna, has basically the Helm charts and knows the configuration. That's what we do.
And how do you trigger the
deployment? So we have pretty comprehensive GitLab CI pipelines.
Okay, with GitLab CI.
Yeah, and through that we have like the plan stages and then the deployment. It's still a manual approval at Sivo to have it like deployed to our production regions.
Okay. And did you consider ArgoCD?
We didn't yet, but it was mainly when I joined Sivo, we did the entire stack in Terraform and Terragrant. So we didn't consider that yet, no.
Okay.
Are there any like online questions or any other questions?
We have a question from the chat. If we have Kubernetes clusters running on multi-cloud architecture, do we have to install Crossplane separately for different cloud or just install on any cluster?
So so what you do is you only have one cluster that runs Crossplane. It's your single point of truth in that case. You have only this one cluster that has Crossplane installed, and it can be any cluster, right? And then this one cluster, let's say it's on Sivo. You can give it multiple providers. You can give it the GCP provider. You can give it the Azure provider. And this one cluster over here has then those different providers. So for example, it has the Sivo provider, it's the Azure provider, and everything. And that tells us one cluster of how to connect to the other, platforms. That's basically, and then you have like this one cluster with which you manage your infrastructure, and it's then deploying whatever infrastructure you want to spin up on those different platforms in those different regions. That's how you would go about it, I assume. I haven't tried that yet, so that's, I think, from what I've understood and heard from them, that's how you would go about it. They also have a very active Slack community, Crossplane, so if you have any questions, I highly suggest you to jump in there, because then you can talk to the maintainers directly. Yeah.
So in your example, it's more or less some kind of management. In your case, it's some kind of management cluster, which is applying the resources for the Civo, the GCP cluster or
Yeah.
a Civo cluster or whatever.
Yeah, in this case, I just, for demo purposes, I could have had the test cluster also just locally on my Docker Kubernetes or a kind cluster just locally running. It wouldn't have mattered as long as I give it the provider that tells it how to connect to GCP and then spin up the example cluster. That's ultimately it. Like, it wouldn't have the original test cluster could have been anywhere. I just put it there for simplicity, but I could have also had it anywhere else. It doesn't really matter where I have the original cluster. And yeah, in this case, the power really, or like what I see, the value I see with Crossplane specifically is if you want to have additional checks in place. If you have large teams and you want to ensure that they can only create certain infrastructure resources and it's always the same, right? You want to have it in a replicatable fashion, your infrastructure, versus telling people of like, oh, go to AWS, click these and these and these buttons and configure this and this. Because if you've seen AWS, it can get pretty complex to configure stuff through the UI. So if you have everything defined in code, you can just give people the YAML manifest, and that's basically what I did with this, right? I just took the YAML manifest from their example, and they have within each of their providers, they have specific examples. So you can just take that, and you can go ahead and, for some people, it's easier to just do it through YAML files versus clicking the buttons and trying to make it work. Yeah. Any other questions? Is there anything else online or any comments or confusion or?
I have a question. Can I deploy other resources like databases or something else? So it's not only clusters.
So you, for example, this configuration here, this connection is based for then to provision, I think, a database here. So you have different types of resources. So here, for example, this is how you then would spin up this resource. So that's how you would go ahead. And it's through the same provider. So the provider they have the API documentation here, so that can show you how you can, let's go to the Azure one, what you can spin up. So you can spin up all of these resources through Crossplane. Is this big enough? Let me make it bigger. So you can spin all of this up, right? It tells you how you can define your YAML manifest to spin up those resources. And then, yeah.
Thanks.
And you always have to reference the provider within the YAML manifest. Yeah?
So you can use, just like to complete your answer, you can use Crossplane to deploy a database in Azure but there are also in the organization of Crossplane as a contrib, there are plugins to manage resources with Crossplane on your Kubernetes cluster. So there's like a Kafka plugin or whatever, Min.io and stuff like that. So if you have like Min.io running on your cluster or Kafka and you wanted to configure a stream or a bucket, you could do this again with Crossplane. It's just like not the official provider.
Yeah.
So you have like a Postgres provider, Kafka provider, whatever. Just like look in the huge list of, maybe you can show the organization, the Crossplane org contrib, and then there's like a huge list there.
They have here like community contributed ones.
Yeah,
so
exactly.
These are all the...
There's even one for GitHub.
Yes,
For
you can
everything.
create repositories. Yeah.
Yeah. And there's another one.
Another question?
Yeah. You showed us how to spin up some services with Crossplane. For example, when you use Terraform, you have always the problem if you don't spin up a service, but you change a service, you have to make sure the service is updated and not deleted and started new. Because the database was a really good example when all this process is automated. How do you make sure that the database isn't deleted and spun up new?
That's a good question. I think, so the way I haven't actually thought actively about this question, but whenever I made changes to a resource, it would just update it. So for instance, I don't know if we can, let's try maybe, is it already finished building? So it's finished building, so it has number of nodes 3. Let's try that out, right? Let's go to the Git repository and update this, right? And see if it's going to delete the class, right? That's the best way to find out, no? Because I don't know 100%. I would think that it's just going to update it. So
I think with the
if I change this to
the
5,
nodes, it would update it. But if you, for example, change the VPC or the
think it
IP range
depends what
behind
you
of it, when you have an EKS cluster, I had the problem a few weeks before. It
Oh, you
would
used it? No.
no, not Crossplane, but
Yeah.
Terraform. But when I wanted to
yeah.
change the IP range of the cluster, it would have deleted the whole
Yeah.
cluster and spun out a
Yeah, that's
new.
something
So
we also have to be very careful in Terraform on. Yeah. Yeah, it's similar when you, yeah, go ahead.
Please repeat.
Yeah, I think some of the fields are immutable in some of the CRDs to avoid these kind of issues where you need to delete something to recreate it somewhere else.
Yeah, yeah, I would think so. We have the same issue with Terraform that when you change a Helm chart, you have to update the version of the Helm chart, and then it's going to delete the resources and spin them up again, right? So if you have, like with your infrastructure, it's just going to delete it and spin it up. So you have to be careful with how you change things. Yeah, yeah, that's a good question. Anything else? Good one.
We have another question from the chat. What's your experience with with wrapping Terraform models into Crossplane resources? Do you know of any common pitfalls when walking down that path?
I haven't. I don't think people use. I don't know. I haven't used Terraform and Crossplane in combination, so I can't really comment. There are lots of resources from the Crossplane team as well on the differences, like when you would use which. I don't think they are used for exactly the same use cases. I wouldn't assume they are used for the same use case. I would think that you use, for example, Crossplane more for the infrastructure part of when you actually want to create the infrastructure, versus then you would, for example, use Terraform on top if you want to make lots of updates continuously. Like, I would think they are different use cases. That would be just my thoughts on having used both independently, that you wouldn't really like combine them. But happy to hear other thoughts. Yeah.
Does someone here like to add something? Probably from his own experience.
Yeah. Somebody used Terraform and
No one did switch?
would use one for and the other. Like Crossplane for some aspects of the infrastructure and application management, and Terraform for the other parts. The thing is, I mean, with Crossplane, you have to define everything as YAML manifest, right? So, I mean, with Terraform and then Helm, you kind of do that too, but I think Terraform is a bit more dynamic in a way. That's how I would describe it, the use of it. But yeah, I would say there are different use cases, different use cases when you would use one or the other, right? Like Crossplane is especially useful when you have multiple regions, multiple platforms, and lots of different components, right? That are on different platforms and that you want to combine in one central place where you manage everything. That's kind of where the value comes, yeah.
And now we have food.
But one more thing that I kind of wanted to manage. Sivo is hiring. We are hiring 2 Go developers and one site reliability engineer. So if you want to join my site reliability engineering team, or like the team that I'm part of, we have amazing work perks, 4-day work week, and just FYI that there are open jobs at Sivo.
Anais, thank you very much
Thank
for your
you.
talk. And now I would say, let's go and finish the pizzas.